Okay, hi everybody. We're going to take a look at a quick example here of rationalizing and then simplifying. So we've got the square root of 2x plus 3 minus 3 over x minus 3. And remember, rationalizing doesn't always have to refer to the denominator. Sometimes we can rationalize the numerator, whoops, like we're doing in this particular question right here. So we're going to take 2x plus 3 minus 3 over x minus 3. We want to get rid of that radical in the numerator. So what we're going to do is we're going to multiply by the conjugate of the numerator, and that's going to be the square root of 2x plus 3 plus 3. And we have to do that to both numerator and denominator. Remember, we need to multiply by 1, essentially, here. We can't change the value of it, and if all you do is multiply to the numerator, then you've multiplied by a value that's changing the overall value. But multiplying by 1 does nothing. And so when I do this, I am going to get 2x plus 3, because I'm going to square the radical there, so it's going to get rid of the radical, minus 9. And it's that minus 9 that sometimes becomes a problem for people. Remember that when I multiply these together here, I multiply these together, the middle terms are going to cancel because it's a conjugate, and then I multiply these two together, and negative 3 multiplied by 3 is going to be negative 9. And that's why that negative 9 is there. In the denominator, I'm going to leave things basically the way they are for a moment here. Now I've got 2x plus 3 minus 9 is going to be 2x minus 6. And then I can't help but notice that in that numerator, there is a common factor of 2. And if I take that out, I get 2 multiplied by x minus 3. This will be over x minus 3, and I like that. I'm seeing a common factor there, over the square root of 2x plus 3. Those two are going to cancel, and then I'm going to be left with just the 2 over the square root of 2x plus 3 plus 3. And that's fantastic. That's a great answer. It's not exactly equal. Okay, this little equal right here is not exactly true until I state that x cannot equal 3. That restriction has been there since the beginning of the problem, and it's only in this last step where I got rid of the factors of x minus 3 that disappeared. So now, by including that, I force my end result to be entirely equal to my the question there, but I've got it in a form where I've rationalized the numerator. I hope that makes sense.